Before we go through some examples, let's review what we've learned. So there are two special right triangles. We have the isosceles right, and then we have half of an equilateral triangle. So an isosceles right triangle has the right angle and then the congruent sides. So knowing what I know about right triangles and knowing what I know about an isosceles triangle, we learned that those two angles are always going to be 45 degrees. And so the ratio of the angle measures is 45, 45, 90. And then we also learned that with the ratio of the angle measures comes a ratio of the sides. And so the ratio of the sides, so if this side length was x, then because these two side lengths are the same, that also has to be x. And then what we found out every single time was the hypotenuse was always the leg, the length of the leg, times the square root of 2, or x times the square root of 2. So for example, if I have an isosceles right triangle, and let's say that the leg is 11 units long. Okay, so I can set up my ratios: 45, 45, 90, x, x, x times the square root of 2. And I can figure out the length of the remaining sides. So 45 and the 45 and the 90. So this 11 is opposite of the 49, so I know that x has a value of 11. So using what I know, I can fill out the remaining sides. So that means this leg has to be 11, and this one's going to be 11 times the square root of 2. So 11 and 11 times the square root of 2. Now we're going to look at some harder examples and figure out some missing pieces here in a minute, but this is just the basics. Okay, so the half of the equilateral triangle. So what we learned, we have an equilateral triangle and we know that all sides are congruent. So this side length here is the same length as that side length there. But what we also learned was when we drop down a median, what that does is it cuts this bottom segment into two congruent parts. And then from there we were able to figure out, well, I know this angle is 60 degrees because it's all angles in an equilateral triangle are 60. And this median, we justified and proved that these two triangles were congruent. So this angle has been cut in half, and there's my 30-degree angle. So this is the 30 degrees, 60 degrees. And then this is my right angle. So what we also was able to figure out, and I'm going to start with an example here. So if I knew that this one was, let's go with 12 units long, then this segment, because it's now being cut into two equal parts, if the whole segment is 12, then hey, this half has to be 6. And then what we learned in that investigation was the median was always the length of the smaller side here times the square root of 3. So if we focus on just the half, okay, if I could draw a better picture than that. So here's my 60-degree angle. Here's my 30-degree angle. And this length, so I'm going to set up my ratio of my angles, 30, 60, 90. So this leg, let's call it x. Well, the hypotenuse is always going to be double that. So we called it 2x. And the length of the longer leg, or the median, the leg that's opposite of the 60 degrees, was always the shorter leg times the square root of 3. So now we have a ratio that goes along with the lengths of the sides of half an equilateral triangle. Now again, I know that this doesn't seem important, but when you get to Math 3 and you start to learn about trig functions and you learn about the unit circle, special right triangles is super important. So this unit is probably one of the most important units when it comes to understanding what's going to come in Math 3 and then also into pre-calculus. So go ahead and watch the next slides in the video so that we can apply what we've learned and look at some examples.